right, I'm going to be going over 3 questions from the Chapter 5 test, and these are the ones that were missed most frequently by the students in my sections of Math 100B, and we'll start with number 14. So we're solving this equation right here. So since it's a quadratic equation, meaning that the highest power is 2, highest power on the variable is 2, then we want to solve this by factoring if possible. So we're going to look at what we have here, and first, always when factoring, think about whether or not there's a greatest common factor. And in this case there definitely is. 24 and 6 have 6 as a greatest common factor, and then n squared and n have n as a common factor. So 6n can be factored out of both of those terms, and when you do that you're left with 4n plus 1. And it's still set equal to 0. And anytime you're factoring, I highly recommend that you take the time, especially on a test, to double check that you factored correctly by just using the distributive property. So if I do that and check 6n times 4n, I do get 24n squared. And if I check 6n times 1, I do get 6n. And so that verifies that I did the factoring correctly. All right, once I have it factored, then I'm going to use the zero product property, which says that we just take each factor and set it equal to 0. This only works if the equation is set equal to 0, because the zero product property says that if I have a product that equals 0, then one of two things has to be true. Either the first factor of the product equals 0, or the second factor of the product equals 0. So I have to check both those possibilities. In this case, if the first factor equals 0, that just means that n is 0. And in the second case, if the second factor equals 0, I can solve that, and I get n equals -1/4. I'm not going to take the time to do it right now, but I also highly recommend that you check your answers. Check by just going back to the original equation, replacing n with what it equals. So we can check n equals 0 by replacing n with 0 and seeing whether or not 24 times 0 squared plus 6 times 0 equals 0, and you'll find that it does. It also works when you check -1/4. 24 times -1/4 squared plus 6 times -1/4 also equals 0. And that check can be done with a calculator pretty easily, so it's definitely worth your time to check your work. All right, let's move on to the next question. Okay, so here we have number 16, and this is a problem, a word problem, a story problem. So our first task is to translate these words into a number sentence. So let's start with the product of two consecutive integers. So product means multiply, and two consecutive integers means two integers that are 1 apart. So since we don't know what they are, we can call one of them x, and then the second one is just 1 away from x, so it's x plus 1. You could also do x and x minus 1. That would still represent two integers that are 1 apart. In this case, x is the lower of the two and x plus 1 is the higher of the two. So the product of two consecutive integers would be multiply those together. And then it says is. Is often means equals, as it does in this case. What we're saying is that the product is the same as, or is equal to, and then the next thing is 41 more than their sum. So that means take their sum, which means add the two integers together, x and x plus 1, add them together. And then 41 more than that means add another 41. Okay, let's do a little simplifying and see what we have. On the right, I've got x and x, that's 2x, and 1 plus 41, that's 42. On the left, let's use the distributive property and see if that helps us. So x times x is x squared, and x times 1 is x. Alright, so now I recognize that I have a quadratic equation because of that squared there. So that suggests that I should set this equal to 0 and try to factor. So let's go ahead and see where that leads us. So I'm just subtracting 2x from each side and 42 from each side so that I get 0 on the right. And on the left I have x squared plus x minus 2x. That would be minus x and then minus 42. Alright, so in order to factor this, I need to find two things that multiplied together equal negative 42, but when added together equal negative 1, because this is really a negative 1 here. And so it shouldn't take you too long to figure out that that's going to be negative 7 and positive 6. And since this is a simple one with no letter here, or no number in front of the x squared other than the hidden 1, it's a pretty straightforward factoring. It's x minus 7 and x plus 6. And like I mentioned with the previous problem, I highly recommend that you double check your work by using the distributive property and making sure that what you have here does indeed match up to what you have here. I'm not going to take the time to do that now though. Let's just go ahead and move to using the zero product property. So we're going to now set each factor equal to 0. And those are pretty straightforward equations. If x minus 7 equals 0, then x must be 7. And if x plus 6 equals 0, then x must be negative 6. So what we have are two distinct possibilities for x. But we also want to come up with, it says find the integers. So we have two possibilities for what the lower of the two integers is. Then the next integer is going to be just one higher. So if x is 7, then x plus 1 is 8. And if x is negative 6, then x plus 1 is negative 5. Negative 6 plus 1 is negative 5. So we have either 7 and 8 as our two integers, or negative 6 and negative 5 as our two integers. So it looks like this is the right choice here. Another thing we can do is just make sure that this makes sense. The product of 7 and 8 is 56. The sum of 7 and 8 is 15. And 56 is 41 more than 15. So 7 and 8 definitely works. Now let's try negative 6 and negative 5. The product of negative 6 and negative 5 is 30. The sum of negative 6 and negative 5 is negative 11. Again, 30 is 41 more than negative 11, so that checks out too. Alright, well, let's get ready to go on to the next one. Okay, so here's number 24, and this is the last one we'll look at together. The question is, determine whether the following is a perfect square trinomial. So perfect square trinomials, that means it's a trinomial that can be factored into the form, I'm going to write a minus or plus b squared. And when you expand a plus b squared, distributive property, you get a squared plus ab plus ba. But BA and AB are the same thing, so I'm just going to write AB again, plus B squared. And then AB plus AB, that's 2AB. So that's what A plus B quantity squared equals. And if it happens to be a minus instead of a plus, it's pretty easy to follow the same process, and the only thing that's different is you have minus 2ab, but you still have plus b squared. So on the surface, this is a candidate for being a perfect square trinomial because we have right here something squared. So our a could be x. The first term in our binomial could be x. And here we have something squared as well. We have 400, which is 20 squared, so b could be 20. Now the fact that this is a minus here means that this has to be a minus here. So it's at least plausible that we have a perfect square trinomial because we have something squared as our first term and something squared as our last term. But the trick is, what's the middle term? And you can either expand x minus 20 squared fully, or you can just focus on what this is saying. This is saying that the middle term should be negative 2 times a times b. Or in other words, in this case, it should be negative 40x. Instead, we have negative 20x. If it's hard to see that that's what we're after, go ahead and take the time to expand this. X minus 20. And then use the distributive property. So x times x is x squared. X times negative 20 is negative 20x. Negative 20 times x is another negative 20x. And negative 20 times negative 20 is positive 400. And so we have x squared minus 40x plus 400. Not x squared minus 20x plus 400. So in fact, what we've just shown is that this is not a perfect square trinomial. The answer is no. All right, well, hopefully that's helpful. And if you're planning on taking the Chapter 5 test retake, make sure you go over any other questions that you missed other than these 3. And good luck on that. And if you haven't already taken the final, good luck with that too. Thanks.